let's do this. So first thing, when you're solving equations, firstly, please always remember inverse operations. This is going to be a part of solving equations for the rest of your mathematical career, however long that is, and you need to remember those inverse operations. The next thing I need you to remember is that what we're going to do in this lesson now is sometimes there is distribution. And when there is distribution, remember, means multiplication. So we have to do that first. And you can almost think of it in terms of BODMAS. BODMAS tells us that we should be dealing with any multiplication before we deal with any adding or subtracting. So we always do our distribution first, and then we move on to dealing with our inverse operations. And this is what we're going to have a look at today. So we're going to look at one, I'm going to explain one, and then hopefully you'll be able to try one or two by yourselves. So let's have a look at this first example here. We've got 2 times x minus 1 is equal to 4. Now, I'm sure some of you could do this quite easily, and that's absolutely fine. But if we work through this together, as I said, the very first thing that you always do when you see that there is multiplication or there's distribution is you need to do the distribution first. So that means that I'm going to take this coefficient of 2 and I'm going to multiply it with the x, whoopsie, and the negative 1. Now, most of you can probably do that in your head, but just in case, we've got 2 times x. It's going really well. It's going even better. 2 times x and 2 times that negative 1. So remember, guys, 2 times x, positive times a positive is positive, and 2 times x is 2x. 2 times negative 1, a positive times a negative is a negative. 1 times 2 is 2. So what we have on the left-hand side, once we've distributed, is 2x minus 2 is equal to 4. And now this looks like an equation that we were dealing with last week. We've got an x term, we've got some constants we need to solve. So this is now where our inverse operations comes in. Excuse me. So our second step is now to solve using those inverse. And remember, we can also say opposite. If you're more comfortable with opposite, that's fine. Operations. Sorry, I forgot what I wrote down there. Now, when you are doing this, basically what you're wanting to do is you are wanting to get all your x terms to one side or your variable terms to one side. It won't always be an x. I always get them, or I always put my variable terms on the left because I like my answer to read x equals or variable equals. And then we want to get all our constants, all the numbers by themselves, to the other side of the equal sign. So if you're putting your variables on the left, all your constants should be on the right. And this is now where the inverse operations comes in. So I'm happy with 2x on the left-hand side. What I'm not happy with is this negative 2 on the left. So I want to bring it over to join the constant 4. The second you move a term over the equal sign, you need to be using your inverse or opposite operations. So that therefore means that the 2x is going to be left by itself on the left, but now on the right-hand side, you're going to have 4 plus 2, because by bringing that negative 2 over, the sign has changed. We can very easily add 4 and 2, hopefully. That gives us 6. And now we continue solving for x. The goal is to get x alone. So what I want to do is I need to get rid of that 2 in front of it. Now, guys, remember, this is saying 2 times x. So again, inverse operations, I need to do the opposite of multiplication, which is to divide. So I'm going to divide the side by 2 because we know that 2 divided by 2 will give me that x that I'm wanting. But if you're going to divide the left by 2, you also need to divide the right-hand side by 2. This results in an answer of x is equal to 3, because 6 divided by 2 is 3. Now remember, grade 8, you can always check yourself. So if you're not 100% certain that your answer is correct, do a check. This check you don't have to show You only have to show it if we ask you to check your answer in the test or an exam. This you do on a rough piece of paper or quickly on the side in pencil. The point of the check is that we want to show that the left-hand side is equal to the right-hand side. And through our check, we use substitution. So 2 times, we've worked out x is 3. So I replace this x with the 3. 3 minus 1 should equal 4. In the bracket, 3 minus 1 is 2. So we've got 2 times 2. And we know that 2 times 2 is equal to 4. Because the left-hand side is equal to the right-hand side, my value or my answer of x equals 3 is correct. All right, so please remember that when you have distribution, you need to do the distribution first, and then only do you start using your inverse operations. Your inverse operations means that you are using the opposite operation to what the equation originally said. And also, if you are feeling unsure, if you just want to double check what you've done, use substitution to check that the left-hand side is equal to the right-hand side. So you're taking screenshots, and if you have any questions, now is the time for you to raise your hand and ask me any questions that you may have. Wandle?
Hello, ma'am. How are you?
Evening, I'm good. How are you?
I'm good, ma'am. Ma'am, what does the LHS and RHS mean?
So it just means to check that the left-hand side, so LHS, left-hand side, is equal to the right-hand side. That's how we make sure our answer is correct.
Okay, thank you, ma'am.
Sure. Any other questions, grade 8s? Remember, you can raise your hand now. Otherwise, we're going to have a look at another one. Make sure you've got your screenshots. Cameron, we are going to deal with a situation where we've got x on both sides, so don't stress. We're coming to that. Nothing changes though. We still sort of follow the same steps. It just means that we might have to move one of the x terms to join the other x terms, but the method or the steps don't change. But we are going to have a look at an example like that. Okay, guys, I'm assuming we've all got our screenshots. Let's move on and have a look at another one. So this is now exactly what Cameron was asking. What happens if we've got x on both sides? We can see we've got x on both sides here. But again, nothing changes. We see that we've got distribution. So that's the very first thing that we do. So I'm going to have to multiply. If we look on the left-hand side, this 2 to the x and to the 2. And on the right-hand side, the 3 to the 2x and the minus 1. So if we do that together, 2 times x is 2x, 2 times 2 is 4, so 2x plus 4 on the left. On the right, 3 times 2x is 6x, 3 times negative 1, negative 3. So now we have a situation of we've got x's on both sides and we've got numbers on both sides. But remember, if we go back up here, our second step said that we solve using inverse operations. And to do this, we get all of our x's on one side, all of our constants on the other side. Now, again, I like to put my x's on the left. So what that means is I'm going to have to take this 6x and move it over to the left-hand side. But the second I do that, it becomes minus 6x. In the same sort of thought, I want this 4 to join the negative 3. But the second I move it over, it becomes minus 4. Inverse operations. So what I now have on the left-hand side is 2x. I'm going to do my best to try and color coordinate as much as possible. 2x minus 6x, because I brought the 6x over, it becomes negative, is equal to minus 3, which stayed there. I didn't do anything with it. But now I'm bringing the plus 4 over, so minus 4. So Cameron, hopefully this is answering your question. Everyone else who maybe was wondering what happens, this is what happens. Get all of your x terms on one side, get the constants on the other side. Now we simplify the situation. 2x minus 6x. So you've got 2 x's and you're taking 6 away. That leaves you with negative 4x. On the right, you've got minus 3 minus another 4, so that gives you negative 7. And then again, think about your inverse operations. The goal is to get that x alone. So what I want to do is I now want to divide by negative 4 so that I get just x by itself. But if I divide the left by negative 4, I also need to divide the right by negative 4. That therefore leaves me with x is equal to, now remember, a negative divided by negative is a positive. So x is equal to positive 7 over 4. Now, guys, we prefer improper fractions, but it is not wrong to write this as 1 3/4 or 1,75, but we prefer improper fractions. It must be simplified. And as you move, sure, I can't multitask tonight. As you move on with maths, you're going to find that improper fractions is generally what you want to be working with in any case. So if you can get into the habit of using or leaving your answers in improper fractions, it will make life easier. But obviously, as you go up, hopefully you'll be more comfortable with that. And so if you can leave it as an improper fraction, if it really bugs you, 1 3/4 or 1,75 is fine as well. Okay, so guys, take your screenshots. If anyone has any questions, now's the time to raise your hand and ask me. Otherwise, I'm going to give you one to try by yourselves. Luanle?
Ma'am, why do we have to divide by negative 4?
Because remember, we want to get x alone. We don't want minus 4x, we just want x. So we need to get rid of the coefficient, and because it's minus 4 times x, the inverse operation is to divide.
Oh, okay, ma'am, thanks.
Sure. And Kuleleko, I've just answered your questions. I hope you were listening and have your answer. Right, guys, I hope we've all taken our screenshots. So what I want is I want you guys to try question 3. So remember, distribute first, and then you can get all your x terms to one side, your constants to the other side, and solve for x. Distribute. Remember those inverse operations. They are so important when solving equations. And find a value or find a solution for x. Alexandra, the answer to your question was given at the beginning of the lesson. So I would suggest we listen in future. However, guys, yes, we do geometry. Geometry is our next 2 sections that we're doing. I even at the beginning of the lesson put up exactly what is coming up for you. Please remember, grade 8, you want to get a positive x in your solution. We are solving for positive 1x essentially. So always make sure that x has a positive 1 coefficient in your final answer. Okay, if you were late, we get that things happen. Remember that the lesson is recorded and you can go back and rewatch it if need be. Same thing, guys, if you have load shedding, we get it. go and watch the recording when you are able to. I'm going to say it again. Please make sure you are solving for positive 1x. Otherwise, you have not solved for x. It should be positive 1x equals your answer. A lot of you are forgetting inverse operations. So just by the answers we're getting, I can see that you are not doing your inverse operations. I have yet to see the correct answer come through. I'm going to give you 1 more minute. And then make sure you mark your work as I go through it. Okay, let's have a look. So first thing we're going to do is we're going to distribute. So we need to multiply the 2 to the x into the negative 4 and the 3 to the x into the negative 2. What that means is that on the left-hand side, we've got 2x minus 8 is equal to 3x minus 6. Then we still have this minus 2. It hasn't gone anywhere. It just wasn't part of my distribution. And guys, hopefully what you see is that on the right-hand side, the minus 6 and the minus 2 are like terms. So what I would do is I would add them or subtract them because it means that we end up with one less term to deal with. So that becomes 3x minus 8. Now we get all of our terms to the sides we want. So I am going to bring the 3x over, which means that it's going to have to become minus 3x. And then I'm going to bring this negative 8 over, which means it's going to have to become plus 8. So on the left, I've got 2x. I'm bringing the 3x over, so it becomes minus 3x is equal to the negative 8 stayed there. But now I'm bringing the negative 8 from the left over, so it becomes plus 8. On the left, 2x minus 3x gives us negative 1x. And now be careful, and this is why I'm saying a lot of you were not doing your inverse operations. Minus 8 plus 8 is 0. If you've got negative 8 and you add 8 to it, you end up with 0. Which means that actually x is just equal to 0. But if we're not too sure why, remember I said to you, you always want to solve for a positive 1x. Which means that we need to divide both sides by negative 1. So that we get that x alone. Now 0 divided by anything, whether it's 0 divided by negative 1 or 0 divided by 20 billion is 0. And so x is equal to 0. Again, if you aren't sure, do your check. So if we do a quick check here, remember we're checking that the left is equal to the right. 2 times 0 minus 4 should be equal to 3 times 0 minus 2 minus 2. In the bracket, 0 minus 4 is negative 4. On the right in the bracket, 0 minus 2 is minus 2. 2 times negative 4 is negative 8. 3 times negative 2 is negative 6 minus 2. And so negative 8 is equal to negative 8. That means that my answer of 0 is correct. So what a lot of you did not do was, I don't know, step number 3, I suppose. A lot of you did not use inverse operations correctly here. And so what you ended up with was negative 16. You did not change the minus 8 to a plus 8 when you brought it over, which means that you were getting an incorrect answer. So please make sure that you use your inverse operations correctly. Right, take your screenshots. If anyone has any questions, now's the time to raise your hand. Otherwise, I think we're going to have a little bit of a brain break before we carry on. Ortile, how did we get negative 8 on step 3? Remember the negative 8. Just get a highlighter. So I said minus 6 minus 2, and that gave me minus 8. And that then just carried over because I didn't move that minus 8 from the right-hand side. It stayed there, so it needed to continue on to the next step. Hope that answers the question. But because it didn't move, it stayed exactly where it was. Okay, so guys, again, screenshots. If you have questions, you can raise your hand or you can ask in the chat. That's fine. Right, let's take a brain break. We're going to come back to that one. I feel like we might have had this joke already, but it's not the end of the world. Okay, so brain break today. What I'm going to say is that you don't necessarily have to start with the first equation for this brain break. What I would do is look at all the information, so all 5 of those equations, and then see which one to start with to help you get to where you need to be. Cameron, you minus the 8 from the 6 and then the 2. Sorry, guys, I'm going to come. You minus the 8 from the 6. I feel like I'm having a bit of a brain fart. Cameron, can you just type out exactly what you did with numbers and operations so that I can be on the same page as you? Because I feel like my brain's maybe just shut down for the evening. Just type it out for me, and then I will be on the same page as you. I do actually have the answer. Let's see if Alex is on it. Oh, Alex, really close. Again, maybe I better just check because if my brain isn't on it today, then. Close, but not 27, not 21. Nice, Ortile. So if you want to, and Jason, well done. So guys, if you, Ortile, I think you got it first. If you want to raise your hand, you can explain it to us. Oh, yes, Cameron, absolutely fine. You just didn't simplify it first. That's absolutely fine. Yes, I'm now on the same page. Absolutely, 100% correct. Right, who would like to raise their hand to explain this brain break? Ortile, are you there? I'm going to give you first crack at it because you were the first person. Okay, Jason, do you want to explain? Because I think you came in second, literally by milliseconds. Okay, would anyone like to raise their hand to explain? Busisiwe, I'm assuming this is to explain this one.
Hi, ma'am.
Hi.
How are you?
I'm okay. How are you?
I'm good, ma'am. So I started by saying 12 plus 12 equals 24. Okay. And that one was for the grape. And then I said 12 times 1 equals 12 for the strawberry. Okay. And then since I got that the strawberry was 12, I said 4 plus 4 plus 4 for the pineapple. So then my final answer was 26 when I added the 12 and 2 for the watermelon.
Perfect. So the watermelon is 2 because 2 plus 4 gives us that 6. And so exactly 12 and 12 is 24 plus 2 is 26. Excellent. Well done. So guys, for this one, like I said, you didn't have to, or you couldn't start with the very first equation because you didn't actually have any information there. So you needed to have a look at everything you were given to see what would be most useful for you to start off with, and then you could go and work out your unknowns. All righty, so that's how we do it. I'm glad we appreciate the joke. Maybe I'm wrong. Maybe we haven't had this joke before. I could be losing my mind. Yeah, that's how we do our brain break here. Are we ready, guys? I feel like this has been the Mondayest of Mondays. All right, so there was a question someone asked, do these get harder? And yes, as with anything in maths, we can keep leveling it up and making it get harder. But this next question is not hard, but it is one where generally we make a very silly mistake. So I want to avoid silly mistakes by having a look at this question and identifying exactly how we don't make silly mistakes. So if we look at question 4, we've got 1 minus x plus 2 is equal to 2x minus 4. So to start off with, I want us to go back for a second to expressions. If you remember algebraic expressions, I said to you that one of the first things we always do when we want to simplify an expression is we want to identify the terms in our expression. And to identify terms, we need to know where the plus and minus signs are so that we can separate them. Now, remember, we don't consider plus or minus signs inside brackets or inside fractions. So what that means is on the left, this minus separates terms, and on the right, that plus separates terms. So what that means is you've got 1 term, 2 terms. Sorry, I don't know what's up with this pen, but we're just going to roll with it. A 3rd term, a 4th term. Separate terms. If they are separate terms, you need to keep them separate. You can't just all of a sudden mash up terms. And this is where a mistake often happens. Often what will happen is people will forget that on the left-hand side, you actually have 2 separate terms. And so when it comes to this distribution, what we need to remember is that there is that invisible 1 in front of the bracket. And what actually needs to be distributed here is a -1 into the bracket. And so what that means is on the left, I've got still the 1 because I haven't done anything with that first term. Like I say, we keep it separate. It's still part of the equation, but we're not doing anything with it yet. And now I'm distributing in that -1. So it's minus x minus 2, because remember, negative times a positive is a negative. And on the right, I still have my 2x plus 4. Now this is doable. Now we can solve. But guys, what I want you to remember is that when you've got multiple terms, always double check to make sure you are multiplying in the correct coefficient. So I'll give you an example now once we finish this off of what often students do, which is a really silly mistake with these sorts of questions. But please make sure you are distributing in the correct value. Right, so I'm going to give you 60 seconds. Finish solving this for me. I want to know what value x is. What is x equal to? I've done the hard part for you. We've done the distribution. So finish this off and solve for x for me. And remember, guys, it's fine to get fractions. It's fine to get decimals. We've already seen that in our examples. I haven't seen any answers on the chat yet. I'm still waiting. I'll give you another minute. Oh, credits, what's happening? Why are there no answers coming through? There we go, Chantal. Keep them coming, guys. Remember to do corrections as we go. That's fine, guys. Ah, the answer's flooded. Okay, let's have a see. So remember, we want all the x's on one side. So what I'm going to do, oh, panic, is I am going to take this 2x and I'm going to bring it over to the left. Actually, no, before I do any of that, let me simplify this left-hand side because 1 and minus 2 are like terms. So I've got minus x, 1 minus 2 is minus 1, and then I've got my 2x plus 4. Guys, if you don't simplify the left, it's fine. You're going to get the same answer. Okay, so it's not the end of the world. I just don't like it, so I'm simplifying it. Now I'm going to bring this 2x over, so it becomes minus 2x. And then in the same sort of thinking, I'm also going to bring this minus 1 to join the 4, so it becomes plus 1. So what I have on the left is minus x minus 2x. And then on the right-hand side, I've still got the 4. But now I'm bringing over that minus 1, so it becomes plus 1. Add your like terms. Minus 1x minus 2x is minus 3x. And then we've got 4 plus 1, which is equal to 5. I don't like that negative 3 being multiplied with the x, so I need to deal with that. That means I'm going to have to divide by negative 3 to get rid of it. But if I divide the left by negative 3, I need to divide the right by negative 3. Now, guys, remember, a positive divided by a negative is a negative. So my value for x here is negative 5 over 3. Now, just as a very random little side note, whenever we are dividing fractions and we've got a positive divided by a negative, we don't really write the negative in the denominator. The negative either gets written in front of the fraction as I've done here or in the numerator. It doesn't matter if you're taking the negative from the denominator and writing it in the numerator. You're still saying that this fraction is negative. My advice, though, is just write the negative in front of the fraction and then there's no confusion. But really, it doesn't matter. As long as you've got a negative somewhere there and you're showing me that you know the answer is negative 5 over 3, that's absolutely fine. Okay, so I'll let you take a screenshot of that now. What I want to show you is a common mistake that often we make. Apparently not. We'll get there in the end. So one of the common mistakes is an example like this, where maybe we have, going to be anything. Let's say we've got 3 plus 2. Okay, so let's say we've got an equation like this. And often what people will do is they'll be like, okay, cool, 3 plus 2 is 5, and then I'll distribute. So the common mistake will be to add those two together and then incorrectly distribute a 5 into the bracket. This is wrong. Why is it wrong? Well, it's wrong because of what I spoke about right at the start. If you've got 3 plus 2 times the bracket x minus 3, is equal to 2x plus 1. What you need to remember is that you have got separate terms. This is a term by itself. The 2 times a bracket is another term by itself, and the 2x and the 1. What you need to distribute is this 2 into the bracket. The 3 and the 2 are two completely separate terms. You cannot just mush them together. They are separate. They need to stay separate until you have dealt with the distribution. So only once you have distributed to get 3 plus 2x minus 6 equals 2x plus 1, and so on. Only once you've done that can you now simplify. But this is the correct way to deal with something like that. Please do not add the 3 plus 2. Even if it says, for example, 4 minus 3, x minus 3. Don't mush terms. Terms are separate. Keep them separate until the distribution has been completed. So that is a very, very common mistake that we make. Please don't make it. Brenda, where did so the negative 2 went because I saw that 1 and minus 2 were like terms. So 1 minus 2 gave me minus 1. All I did was simplify. You don't have to. I just find it a bit easier to work with less terms. But basically, that's where the minus 2 went. I used it in my simplification. Right, so grade 8s, please take screenshots. And again, please don't make this mistake. It is so common. Everyone does it. Don't do it. Okay, I have grade 11s who still make this mistake. Just make sure that you are very clear on where your terms are and what needs to be distributed. Right, any other questions on this one? You can raise your hand, you can ask me, otherwise we're going to have a look at another example. The division of 3 turns in, well, it didn't turn into negative 3, it was negative 3. So because this x minus 2x gave me minus 3x, I needed to get rid of the minus 3x being multiplied with the x. So that's why I divided by a negative 3, because that's what the coefficient was. So the negative 3 came from me adding or subtracting the like terms there, and then needing to get rid of the coefficient. Hope that makes sense. So one day, what do you mean how? If you want to raise your hand, you can ask. Otherwise, try explain to me, what do you mean how? Okay, yeah, one day.
Okay, ma'am. So you know what I'm trying to say, ma'am. So, ma'am,
Well,
you see
explain
that.
it. Yeah.
Okay, the negative x and the negative 2x, right? Since we got that from we got negative 3. So my question is, do we also have to divide the negative 2? Not divide, actually. We have to bring down negative 2, and negative 1 added together, which gave negative 3. So do we have to divide 3x by negative 3?
Yes. Yes. Well, yeah, because remember, minus x minus 2x gives you minus 3x. And because we don't want the minus 3, that's what we're dividing by, to essentially divide it away.
Okay, ma'am. Thank you.
Okay. Sorry. All right, guys, let's try another one. Let's remember to mute ourselves as well. Alrighty. So I want you to try this example for me by yourselves. Remember, distribute, add and subtract your like terms, use those inverse operations in order to solve for x. So like I said, I want you to try it by yourself. We'll have a look in 2-3 minutes. Distribute, put all your terms on one side with an x and put all your constants on the other side, and use your inverse operations to solve for x. Remember, if you have questions along the way, you're welcome to put them in the chat, or you're welcome to send Yolanda or myself a message and we can help you. But otherwise, answers on the chat so we can see them and see how you're going. And remember, guys, if you have an answer and you're not 100% sure, substitute in order to check that your x value is correct. Remember to distribute accurately as well. So just think about what happens when you multiply a negative with a positive and what happens when you multiply a negative with a negative. Okay, our first answer is in. Well done. Keep them coming. We're going to check in a second or two. Please make sure you are correctly applying your inverse operations. Everyone who's put an answer in so far, make sure you're doing your check. Doesn't have to be all neat and tidy, but a quick check to make sure. All right, grade 8, let's have a look. I'm a little confused as some of us are getting a certain answer, but let's see. Hopefully you can correct yourselves as we go along. So when we distribute, 3 times x is 3x, 3 times minus 1 minus 3. Negative 2 times x is negative 2x. Negative 2 times positive 2 is, whoopsie daisies, negative 4 is equal to 10. Now, again, you don't have to add and subtract the like terms. I'm going to because I find it a lot easier to have 2 terms on the left rather than the 4 terms I currently have. So those are my like terms. Remember, we group like terms. 3x minus 2x is then just x. Minus 3 minus 4 is minus 7 is equal to 10. So that's why I add and subtract my like terms before I do inverse operations. This equation is a lot easier to work with, but again, you don't have to. What I now see is that I don't want this negative 7 on the left, so I'm going to bring it over, which means it becomes plus 7. So I've got x is equal to 10 plus 7, and we all know that 10 plus 7 is 17. So x is equal to 17. Now, if we just do a quick check to make sure that we agree with our own answer, remember, check left-hand side is equal to the right-hand side. 3 times 17 minus 1 minus 2 times 17 plus 2 is equal to 10. 17 minus 1 is 16, so 3 times 16 minus 2 times 17 plus 2, which is 19. 3 times 16 is 48. Negative 2 times 19 minus 38. 48 minus 38 is 10. 10 is equal to 10, so x equals 17 is the correct answer. So everyone who wasn't getting that, please make sure you have done your correction. I'm not too sure where we got the negative 1 over 6. I was trying to figure that out. I can't see where we got 6 from. But it's probably just a silly mistake that you do know better. It was just a slip of concentration. So maybe this is why we're going to Why are we not saying, oh, riled. Why are we not saying 6x? Well, Mpumelelo, I'm not too sure how we would get 6x, because remember, when we distribute, what we have is 3 times x, which gives us 3x, and negative 2 times x, which gives us negative 2x. When you add them together, so 3x minus 2x, that gives us positive 1x. So we can't get a 6x from the x terms that we have. So maybe that's where we're getting a 6 from. Remember, you're not multiplying them together. You're adding and subtracting them. There's no multiplication in that second step. It's just addition and subtraction. All right, so guys, any other questions? Again, welcome to raise your hands. Please make sure you do have screenshots. Pleasure. So I think maybe that's where that 6 was coming from. So just make sure you are applying the correct operations. Karabo. Karabo, you there? Okay, Karabo, we can't hear you, so I'm not sure if you're connected to your audio. I'm going to mute you. Just make sure you're connected, and then you can raise your hand again if you feel you are. Otherwise, you're welcome to put your question in the chat. Okay. All right, guys, so really importantly, when you have distribution in your equation, you have to do that first. It goes back to BODMAS. BODMAS tells us that we have to deal with any multiplication that we have before we start adding and subtracting and using our inverse operations. So we must deal with the distribution first so that we can then apply our inverse operations. As we've seen, when you've got x's on both sides of the equation, it doesn't change what you need to do. It just means that you might need to move a term over the equal sign, and then we apply our inverse operations. So that's where we change the sign of the term that we are moving. Okay, so nothing changes really once we introduce distribution. The only thing we need to remember is to do distribution first before we apply our inverse operations. Otherwise, it stays the same. We're not changing anything drastically. It still says the same sort of order of work as what we have been doing last week.